Okay, so now we could talk about population inferences, or stuff we can infer or deduce or determine regarding data when we see it. So let's say this is a survey that was taken among these kids. Of them, 10 said they prefer the color blue, 8 said they prefer the color green, and 2 said they prefer the color red. So one of the first questions we can ask is how many kids in total were surveyed? And that would be 10 plus 8 plus 2, which of course would be 20. So we're going to use that number 20 a lot, so it's good to kind of keep that in our brain. This is a total here of 20. We can even extend that graph a little bit if we wanted to. Now, if I wanted to find out what percent were blue, I would take that number of blue, 10, over the total, 20. That would give me 1/2, or 50%. Duh. Now, if I wanted to find out how many kids prefer the color green, I would do the same exact thing. I would take that number of green over the total. I might do a quick conversion to be out of 100, which is times 5, which would be 40%. Let's say I wanted to find how many prefer the color red. I would again set that over 20. That would be the same thing as saying over 100 times 5 times 5 is 10. So it gives me 10% of the population surveyed prefer the color red. And if you notice, 50 plus 40 plus 10 does give me 100%. That means everybody was surveyed and everybody counts. So that is one thing we can do with that. Now, there's of course all kinds of other things. We can scale this up, we can scale this down. So the total was 20. Let's go with the blue for a second. The percent of blue again was 50%. Let's say I want to take that and infer, okay, if 300 were surveyed, how many would we expect to like blue? I'm of course paraphrasing for the sake of the question. If surveyed, how many would be blue? So I'll take that 50% number, convert it to a decimal, 0.5, and just multiply it by the new total, 300. 50% of 20 was 10. 50% of 300 should be about 150. Now that is an inference, that is an estimation. It could be a little bit higher, could be a little bit lower, it could be 151 or 155. These things are not always exact sciences. As we know from political polling, it's not always exact, but it gives us a pretty decent idea about what's going on if that were to scale up a little bit. Now, we can do, of course, a lot more than that. We can compare these. So if you want to say, okay, true or false, there were twice as many kids who preferred green as red. Were there twice as many? The answer is no. Of course not. There were 4 times as many, because 2 times 4 is 8. That wouldn't make any sense. We can make a lot of inferences based on this data. Now this is really flexible, so I can't really predict everything you might ever see, but those are the big things. We can find percents. We can scale up. We can scale down. And we can, of course, determine relationships. These all come down to how we use the data. I would definitely operate in fraction world. It's definitely going to be the better one to go with for this. Thanks.